Good morning, Algebra 1 CP students. This is a lesson for April 3rd for my B-Day classes and April 6th for my A-Day classes. In this lesson, we're going to review how to multiply binomials, and then we're going to look at slightly more complicated examples, and then we're going to learn how to square binomials. So we are continuing our work with polynomials. All right, we're going to jump to examples, problems right away. Problem number 1 asks you to multiply binomials. Quantity x squared plus 1 times quantity x squared plus 3. Remember, a binomial is just a polynomial with two terms. So the first thing I'm going to do is rewrite the problem that was given to me. Quantity x squared plus 1 times quantity x squared plus 3. I'm multiplying two things by two things. So there are two methods we looked at. The first one is just distribution and using arrows. The second one is using the FOIL acronym. They're really the same thing. They give you the same result, just the process is slightly different. In this example, I'm going to use distribution. So if you recall, what we do in that case is ignore the plus 1 and then just distribute the x squared. So x squared times x squared plus x squared times 3. Just distribute the x squared and ignore the plus 1. And then we're going to ignore the x squared and just distribute the plus 1. So you get 1 times x squared plus 1 times 3. So two things times two things should give you four products, which you see right here. All right, and then the second step, I'm going to multiply. X squared times x squared is x to the fourth. Remember, when you multiply powers with the same base, you add the exponents. X squared times 3 is 3x squared. 1 times x squared is just x squared, and 1 times 3 is 3. The next thing I'm going to do is combine like terms. If you look at the four products, you have one fourth degree term, two second degree terms, and one constant. So the x squared terms are the like terms. 3x squared times 1 plus 1x squared is 4x squared. So I get x to the fourth plus 4x squared plus 3. And this is it. You're going to stop here. Please do not try to simplify further, okay? X to the fourth, 4x squared, and 3 are terms of different dimensions. This is a fourth degree term, this is a squared term, and this is a constant. So you cannot add them any further. This is your result. So quantity x squared plus 1 times quantity x squared plus 3 equals x to the fourth plus 4x squared plus 3. All right. Problem 2, you're asked to multiply binomials 3x minus 5 times negative x squared minus 10. First thing I'm going to do is rewrite the problem that was given to me. The quantity 3x minus 5 times the quantity negative x squared minus 10. Again, I'm multiplying two things by two things. I've learned two ways to do it, either the distribution and the arrows method or the FOIL pattern. In this example, I'm going to apply the FOIL pattern for multiplying two binomials. So first I'm going to write out my acronym FOIL, or first, outer, inner, last. And remember, each of them tells me what to multiply. So first, I'm going to multiply the first terms, 3x times negative x squared, first terms in each binomial, plus outer, I'm going to multiply the outer terms, 3x times negative 10, outer with respect to the multiplication sign. Inner, negative 5 times negative x squared, plus the product of last terms, a negative 5 times negative 10. If you did the distribution and the arrows, you would get the same four products. Next, I'm going to multiply. 3x times negative x squared is negative 3x cubed. X by itself is x to the first power, and when you multiply powers with the same base, you add the powers. So 1 plus 2 is 3. 3x times negative 10 is negative 30x. Negative 5 times negative x squared is positive 5x squared. Negative 5 times negative 10 is positive 50. And then I'm going to combine like terms. But note, there are no like terms to combine. You have a cubic term, a linear term, a quadratic term, and a constant term. So there's no terms with the same variable part. So all I'm going to do is just rewrite rewrite the polynomial from the step above. The last thing I'm going to do, and this is not necessary, but a lot of the books ask you to do it, is rearrange the terms so that the exponents are in descending or decreasing order from left to right. So negative 3x cubed, next is going to come my squared term, or power of 2 plus 5x squared minus 30x plus 50. And that's it. There's nothing else I can do. So the quantity 3x minus 5 times the quantity negative x minus 10 equals negative 3x cubed plus 5x squared minus 30x plus 50. Alright, the next example is something a little new. Remember how to square numbers, like 3 squared is equal to 9? And I also mentioned that polynomials behave in a lot of similar ways that numbers do. You can also square a polynomial. So in this case, you're asked to square the binomial x plus 2 squared. Okay. The first thing I'm going to do is to rewrite the problem. So the quantity x plus 2 squared. Now, you might be tempted to write that that is equal to x squared plus 4. Now, I've never said that was a rule. I never said you can distribute a power to a sum of things. So we're not really sure that's a rule yet. So before we know something is a rule, we have to rely on what we do know to see if we can prove that it's a rule. So what we do know is that squaring something is the same as multiplying it by itself. So that I do know to be true. So let me use that instead. I'm going to rewrite the square as repeated multiplication. The quantity x plus 2 squared is the same as x plus 2 times x plus 2. And this I do know how to deal with. I know how to multiply two binomials. So in this case, let's say I want to apply the FOIL pattern for multiplying two binomials. Write out my acronym FOIL, first, outer, inner, last. So x times x is the product of first terms. X times 2 is the product of outer terms. 2 times x is the product of inner terms. 2 times 2 is the product of last terms. Then I'm going to multiply x squared plus 2x plus 2x plus 4. And then I'm going to combine like terms, x squared plus 4x plus 4. So, and then this I can simplify any further. So the quantity x plus 2 squared, when I square the binomial x plus 2, the resulting polynomial is x squared plus 4x plus 4. Alright, there is a very common mistake students make when squaring binomials, or any polynomials really, but in this case, binomials. And students make that all the way in college as well, okay? So the common mistake is, if you're presented with something like this, the quantity x plus 2 squared, students write that as x squared plus 4, okay? We know that's not true because we actually rewrote squaring x plus 2 as repeated multiplication, and there's actually an x squared plus 4x plus 4. There's a plus 4x term, okay? So we have to remember to avoid this common mistake. You can't if you're squaring a sum, that's not the same thing as the sum of the squares of things inside the parentheses. You actually have to write it out as repeated multiplication and multiply it out.